So today I'm going to go through the solutions to the revision sheet that I've set you. So, question 1. Write down the equation of the lines of the number plane below. So this vertical line, every point that I choose along this vertical line has an x value of 3. So its equation is x equals 3. The horizontal line, every point along this line, if I was to choose any point and write down its coordinates, the y value is always negative 4. So the equation of that line is y equals negative 4. State the equation of the y-axis. Well, this is our y-axis here. Every point along that y-axis has an x value of 0. So the equation is x equals 0. In question 3, we want to find the x and y intercepts for all of these functions. So here's a straight line. The gradient's 4, y-intercept negative 2. So our y-intercept is when x is 0. So I substitute in 0 for x. So y equals 4 times 0. And 4 times 0 is nothing. Take away 2. So our y-intercept is negative 2. For our x-intercept, we substitute in y equals 0. So put in 0 for y equals 4x minus 2. Now we've got an equation, so add 2 to both sides. So I get 2 equals 4x. Divide both sides by 4. And 2 divided by 4 is a half. So my x-intercept is a half. For the next function, y equals a half x. Substituting x is 0. So a half times 0 gives me 0. So it cuts the y-axis at 0. And the x-intercept, I substitute in y is 0. So 0 equals a half x. Multiply both sides by 2 to get rid of the fraction. So I get 0 times 2 is 0. And 2 times a half is 1. I don't need to write the 1. So x is 0. So it actually cuts the y-axis at 0 and x-axis at 0, which is the origin. For the next function, it's written in a different form, what we call general form. And if you've done more of the harder exercises in the textbook, you would have seen these. So the y-intercept, again, substituting x is 0. So 2 times 0 plus y minus 4. 2 zeros are 0. So y minus 4 is 0. Add 4 to both sides, and I get the y-intercept is 4. The x-intercept, substituting y as 0. So replace the y with 0. So 2x plus nothing minus 4. Nothing minus 4 is negative 4. Add 4 to both sides. I get 2x equals 4. Divide both sides by 2, and it cuts the x-axis at 2. With question 4, we have to find the gradient. So we're looking at part A here. We notice this line is a falling line, so we need to make sure we have a negative gradient. So remember, gradient is rise over run. So we're falling from 8 down to 2. So it's a fall of 6. So it's a negative rise, negative 6. And I'm running from minus 6 to minus 2. So I'm running 4. So my gradient is minus 6 over 4. And that simplifies to negative 3 over 2. Remember, with gradient, leave it as an improper fraction. Right? Don't change it to negative 1.5. Leave it as negative 3 on 2. For part B, again, we want rise over run. So our rise is going from 1 up to 3, which is a rise of 2. And our run is going from 3 up to 10, which is a run of 7. So rise of 2, run of 7, so our gradient is 2 over 7. For part C, again, it's a falling line, so it's a negative gradient. And it's falling from minus 4 down to minus 8. So it's a fall of negative 4. So our rise is negative 4. And we're running from negative 8 up to 8. So that's a run of 16. So rise is negative 4. Run is 16. And we get negative 4 over 16, which is the same as negative a quarter. For question 5, we need to plot the point 4, negative 3. So go across 4, down to negative 3, plot that point, and I should be labeling that A, but for some reason my program won't let me do that today. Then the next point, go across -2 up 5. There's my point B, so I should be labeling that B. Join them together, make a right angled triangle, rise and run, and I should be labeling that the point C. Now, if I want to find the length of AC, I'm going from -2 up to 4, so that's a run of 6. I want to find the point or the length of BC. I'm going from 5 down to -3, so I'm falling 8, so my rise is -8. Then the gradient is -8 over 6, which again simplifies to -4 over 3. Leave it as improper for gradient. I also want to find the length of AB using Pythagoras' theorem, so I want to find out how long this line is. So I can use Pythagoras' theorem, this side squared over that side, plus that side squared, is part of the working out. So here's Pythagoras' theorem. So c squared equals -8 squared plus 6 squared. Notice how I've got the -8 in brackets. If I don't put it in brackets, I won't get the right answer. So I need to make sure that when I put a negative, substitute a negative in, I put it in brackets so that I get the right solution. So, do that on the calculator and I get 100. If I don't put the brackets in there, I'm going to get a negative number here. And I can't find the square root of a negative number. So that way I know I've made a mistake. But just be careful, make sure you put that in brackets. Square root of 100 is 10, so the length of AB is going to be 10 units. So question 6, we're going to find the midpoint, so the point in the middle of these 2 points. So I look at the x values for both of them. So I look at this 2 and this 6, and to find the middle of them, I add them together and halve it. Do it all on the calculator. 2 plus 6, 8, divided by 2 gives me 4. Do the same thing with the y values. So the 6 and the 4, add them together, get 10, divided by 2, I get 5. So the midpoint is the point 4, 5. Make sure I write it as a point, so in brackets separated by a comma. Midpoint between the next two, add the x values, 2 plus -4. Do it in brackets, then halve it, I get -1, and halfway between -3 and -5 for the y values is -4. So the midpoint is -1, -4. And part C, find the midpoint between this point and that point. Again, x values, add them together and halve it, and I get 1. And next one, add the y values 0 and 7, halve them, and I get 3.5. Or you can write it as 3.5, it doesn't matter there. So the midpoint is the point 1, 3.5. For question 7, this is a more challenging question, where I'm actually telling you one of the endpoints and the actual midpoint. There's 2 methods. One here is showing all the working. So I know that my x value has to be 2 at the end. I don't know what one of the other endpoints is. Substituting in the x value for the other one, and I solve this equation. So this is the x value of the midpoint. This is the x value of the end point. Alright, normally get rid of that divide by 2 by doing the opposite to both sides. 4 equals x, and x plus -1 is x minus 1, and I don't need the brackets anymore. Add 1 to both sides, and I find that the x value of the end point is 5. Doing the same thing for the y value, substitute this in for my y value there of the midpoint, my y value of the end point, multiply both sides by 2, subtract 4 from both sides, and I get y equals -2. So the other endpoint is the point 5, -2. Now I said that this is one way. Another way is to look at the x values. How do I go from -1 up to 2? Well, I'm going up 3 spots. -1 up to 2 is moving up 3. So move up another 3 from that. 2 plus 3 is 5. And how do I go from 4 to 1? I subtract 3. So subtract another 3 and I get -2. So that's another way of working that out, but this is the proper working out to do so. Being careful with question 8 because it asks us two things to find the gradient and the distance. So I need to know my rise between the 2 points. So the rise is my y values, 5 take away -4. And that gives me a rise of 9. And a run of 2 take away -1, a run of 3. So my gradient is my rise over run, and that simplifies this down to 3. To find my distance, again using Pythagoras Theorem, substituting my rise and my run, and I only want 2 decimal places, so when I work that out, I get a big long decimal. I only want 2 numbers after decimal point, put my line down, check the next digit, it's a large digit, so I add 1 to the digit in front. So the distance between those 2 points is approximately 9.49. With question 9, this equation is not in gradient intercept form, so what I'm going to do is I want the y's to be positive. It already is, so subtract 3x from both sides, and I get 2y equals 7 minus 3x. I don't want 2y, so divide both sides by 2, remember dividing all of it by 2. So 7 divided by 2, -3x divided by 2, and normally I want the x's first, including the sign. So in gradient intercept form, I have y equals -3 on 2x, plus 3.5 or 3.5. For question 10, determine the equation of the line that is perpendicular. There's the key word. So the gradient of this line at the moment is 3. The perpendicular gradient is the opposite sign and the reciprocal. So turning 3 upside down becomes -1/3. Now I can write that in my general equation, y equals mx plus b. So there's my perpendicular gradient. It goes through this point, so I substitute my y value of 5, sorry, my x value of 5 into here, and my y value of 1 into here, and I go and solve that, and I get b is 2 2/3. So y equals -3x plus 2 2/3. In question 11, I want to sketch this. Remember, there's a few different ways. I can do a table of values, but I can see straight away that my y-intercept is +2, so I'm going to plot that point +2. My gradient is 1, there's a 1 there. That as a fraction is 1/1, so that means I'm going to rise 1 every time I run 1. So I rise 1 every time I run 1, I place another point there. I can rise 1, run 1 again, and place a third point there. So now that I've placed at least 3 points, I can see what my straight line is doing, and I'm going to draw a straight line through that, filling up my whole graph. So once I've done that, that's my line y equals x plus 2. So now we're going to do the same thing with y equals 3x minus 2. It's in gradient intercept form. I know it goes through at -2, so I'm going to plot a point at -2. So there's my -2. My gradient is 3, and 3 as a fraction is 3/1. So it's going to rise 3 every time it runs 1. Rise 3 every time it runs 1. So I'm going to plot those points and draw that straight line. So now that I've plotted those points and drawn that straight line, the question does ask the point of intersection. So where do they cross? At this point here, which is across 2 up 4. Now this recording's about to finish, so what I'll do is I'll do the rest of the revision in another recording.